Okay, so graphical user interface. So there are a couple of questions we want to tackle today. First of all, how we can create the graphical programs. And the other one is kind of related. We kind of use while we're doing graphics, we need to use some other codes out there. So how can we benefit from others' codes? And also how can we allow others to see our code as well? So we'll look into that question. So first we'll cover the modules, and then we'll dive into the graphics, which is TK Inter module. So congratulations on finishing the midterm, first of all. You learned a lot of things. You probably didn't realize it that well, but we covered a bunch of stuff in Python. We covered Carol, we did control flow, we covered conditional decisions, loops. We created our own function, we created our own doc test. We covered variables and constant. You probably learned a lot about data types, integer floats, booleans, strings. We were able to introduce you to console program, how we can read files and how we can parse them. And the most important part is the data structure. So you learned lists, dictionaries, nested data structures. And while we're doing it, hopefully you learned the best style to do all that stuff. So congratulations. There's no clapping, but I would like to clap you. Um, so let's see. So from now on, you can probably share your code with others if it's allowed, not as a, during the exam or in the assignments, but you can also benefit from others as well. Like some of the imports we're going to use are shared with us, so we will use them if we're allowed to use them. So we'll talk about modules really quickly. Modules, we have been using this one for a while as well. And it's basically a bunch of other PY files containing some working code for reuse across programs. And these are also called libraries. So you guys remember what kind of libraries we used so far? We used a bunch of libraries. You can type if you like. If you're too shy to talk to me. Math, yes, Aisha, we use math, right? We did the math power, math square root, stuff like that. Uh, anyone? Random, yes, we did the random library. We used the random library. While we're plotting something, we also use matplot library. Yep, that's also. So let's look at, so modules are, in terms of style, they have like short, all lowercase names, and then they use underscore if needed. So they're like, sometimes they're in a package directory of Python modules. If they are bundled together, they are in a package. So we would use them as import module. And then if we need to use the function, we will just refer to the module name and then followed by the function name. And on top of these libraries, we build our own code. So we were able to plot some stuff. We were able to do math. We were able to read the files using sys or the arguments. We also use Carol, if you remember. That's also a special library some people wrote for us, and then we used it. In the graphics, we'll be using some other libraries as well. So let's see how we can create the graphical programs. So we will use the GUI libraries, or GUI modules, they call it. So GUI, in terms of the definition, is basically those are visual elements that you can interact. The whole idea is to interact with the interface. So you're going to use some interactors. They also call interactors, windows, buttons, scroll bars, etc. So user interface is the part where where the user interacts with an application. We have seen the command line interface, which was kind of boring. It was just displaying us a prompt, and then you type in the command and it's executed. Hopefully graphics, the GUI, allows you to a much more, visual input. So without the GUI, all computers used to have these, just command line is just black screen or vice versa. You just type in commands and then you interact with the machine using the command line. Um, in this environment, everything is like the user can only enter data in the order that the machine allows you to interact. So the interaction is already defined. In the GUI environment, it's event-driven. So the user determines the order in which things happen. So that's why it's much more preferred by the user. User causes some events, and then it causes some events, and then we listen to it, and then we can respond to it. So it's a different kind of interaction. Um, Dialog boxes are also used, small windows that display some information with buttons and so on. So those are also preferred. You can respond by clicking on buttons, by saying, okay, cancel, kind of a relationship. So in the GUI libraries, if you look into different operating systems, each have their own GUI system. So the look and the feel can change depending on your operating system. So the GUI modules, there are GUI libraries that support your operating system, GUI system. So the computer's GUI system and the GUI libraries interact together. So there is a library in Python, which is not part of Python. It's a library. It's not a built-in functionality. We call it tkinter. That's used a lot in Python. Um, so there's no actually built-in programming feature in Python. So we have to use the tkinter module, which comes along with Python. So if you think in terms of how it is done, there's the hardware, there's the operating system, and there's something called TCL/TK, which is a special scripting language that allows graphic creation on top of different operating systems. So it's not part of Python. And also, Tinker is not part of Python. It's just a special library. So that's why it stands for TK, and the interface, TK interface actually, TK inter, is an interface between Python and the TK module. So the TK allows us to create the GUI, and that TK inter allows us to talk to the TK with the help of Python. Okay, got it? So you're gonna be using some widgets using TK inter. So the graphical elements that we're gonna have, we call them widgets. And then we'll be creating those widgets. So let's see, there's a list of widgets out there that comes along with tkinter. So we have buttons, canvas, checkbox, entry, and so on. We'll cover these one by one. So first of all, for you to work with this library, you have to import it. You will say import tkinter, okay? And everything is drawn in a canvas. So we have a widget called canvas. And today examples, we will provide some of the code for creating the canvas. What happens is you create a canvas with a specific size. Keep in mind that the origin of the canvas is 0, 0, which is different from Cartesian. It is on the top left side. So the Y will increase when you're going down, unlike Cartesian. In Cartesian, it's minus, right? But in the graphics, when you go down, it's positive values. And when you go to the right-hand side, which is depending on which is right, but if you're going towards this direction, then X will increase. So you have to keep in mind how the XY coordinates works. And TK converts floats, the floating values, to integers to come up with the pixel values. I'm not going to go into the details of why it's floats versus not integers and so on, but the basic reason is floats are not always as dependent as integers. So we have to convert the floats to integers. So we have to define the XY coordinates in terms of integers. So Canvas widget, let's take a look at it. Everything we will create will be inside the canvas. It's a blank, like a space for you to draw your simple two-dimensional shapes. And it uses the screen coordinate system to the top left, which goes down and in positive in Y direction. So it looks something like this. You can specify 0, 0 like that, or you can specify different pixels in the canvas. So to get the syntax, first of all, keep in mind that we need to import the library, and then we need to create our main window. So when you want to create it, we can call it main window equals tkinter.tk. This will create you the window. It will look something like this. It will give you the operating system window. It will talk to the TK in the operating system with the close buttons, increase or maximize screen kind of buttons at the top, and it will create you the window. The next thing is you can create the canvas, which will go inside the window. And the syntax looks something like this. It says, create me a canvas using tkinter.canvas, and you provide the window name and the width and height. So you can make the size anything you want. Okay. Questions so far? Do we need to use self? Not necessarily. You can just say main window, but I'll show you why it's self, because we would want to create this as a class sometimes. If we can create a GUI class, and then if so, if it's part of the class, it makes more sense to use self, right? Self dot whatever. But if it's not part of the class, we can just give it a name and then create it. We'll see both versions. Okay. Once you created a canvas, you would want to, first of all, pack it. It means make sure that you position the widget. And it also makes it visible when the main window is displayed. So it's called for each widget in the window, and it might receive an argument which tells us the position of it. So positioning depends on the order in which widgets were added. So I might use the option like side equal to top, left, right, meaning that everything will be packed according to that option. So we'll show you one example. So after the canvas is created, you need to pack it and then make sure that it's positioned and it's shown in the main window. So let's see a couple of things. Like we can create shapes, really cool shapes. We can create a line, rectangle, oval, arch, polygon, and text. Those are the simple ones. So let's see how we can do those. So first of all, let's take a look at the line. If you want to create a line, you would just say canvas, whatever the name of the canvas is, dot create line. And that takes minimum two things. First